Hello friends, myself Subhash Nagarse from Sri Digambar Jain Gurukul High School, Solapur. I shall welcome to all of you in this 8th standard mathematics. The topic is surface area and volume. Friends, in this previous standards, we have get introduced with the surface area and volume of three-dimensional figures. Recall those shapes, figures that finds around you. In this chapter, we are going to discuss on the following important subtopics of this chapter. Surface area and volume of three-dimensional figures, surface area and volume of a cuboid, surface area and volume of cube, surface area and volume of a cylinder. So, friends, let us start with the introduction of surface area and volume. Surface area and volume of three-dimensional figures. In geometry, there are different shapes and sizes such as sphere, cube, cuboid, cone, cylinder, etc. Each shape has its surface area as well as volume. Surface area and volume are calculated for any three-dimensional geometrical shape. The surface area of any given object is the area of region occupied by the surface of that object, whereas volume is the amount of space available in an object. Surface area of and volume of the cuboid. Friends, a cuboid is a solid with 6 rectangular plane faces. For example, a brick or a matchbox. Each of these is made up of 6 plane faces which are rectangular in shape. Consider the adjoining cuboid. You can see here it is shown. The dimension of this cuboid are length is L, breadth is B and height is H. So friends, what are the different formulas related with this cuboid? First is area of the 4 walls of room. Room is a cuboid shape. So it is also called as a lateral surface area of the cuboid, which is 2 into bracket L plus B into H. Total surface area of this cuboid, yes, it is 2 into bracket LB plus BH plus HL bracket complete. Third, volume of the cuboid, phi, it is given as L into B into H. And the fourth, the diagonal, you can see here a straight line. Diagonal of this cuboid D is under root L square plus B square plus H square. These 4 formulas are important while solving the problems that could be asked on this cuboid. So friends, let us see. The next is surface area and volume of a cube. We know that a cuboid is a cube of its length, breadth and height. If these are equal, then that will become a cube. So in a cube, all the faces are squares which are equal in area and all the edges are equal. A dice is a best example of this cube. So friends, consider the adjoining figure. It is shown here. Cube, the dimensions of this cube are length L, breadth is also L and height is also L. So the 3 dimensions are equal. So what are the formulas? Number 1, area of the 4 walls of this room, which is also a lateral surface area of the cube, is 4L square. Second, total surface area of this cube, S, is 6L square. Volume of a cube, V, is L cube. And diagonal of a cube, it is shown here, D, which could be under root 3 into length. That is the edge of a cube. So let us start with the problems that are based on the cube and cuboid in practice 16.1. So number 1, find the volume of a box if its length, breadth and height are 20 cm, 10.5 cm and 8 cm respectively. Friends, here it is given that length L is 20 cm, breadth B is 10.5 cm and height H is 8 cm. Here we have to find out the volume of this box. So the volume of the box could be written as L into B into H. Now put the values of L, B, H from the above. That is, volume of the box is equal to 20 into 10.5 into 8. So we are getting the product of this as a 1680 cc, means cubic centimeter. So we can write the volume of the box is 1680 cubic centimeter. Problem number 2. A cuboid shaped soap bar has volume 150 cc. Find its thickness if its length is 10 cm and breadth is 5 cm. So friend, here given things are that for a cuboid, here soap bar having length L is 10 cm and breadth B is 5 cm, volume given as a 150 cc. Here we have to find out the thickness of the soap bar, that is H. The formula that could be used, volume of the soap bar is equal to L into B into H. Now we'll put the values. Volume of the soap bar as a 150 is equal to 10 into 5 into H. So here 150 is equal to 50H, 10 into 5 is 50. So 50 brought to the left hand side, it will become 150 upon 50 is equal to H. So 3 is equal to H means H is equal to 3 centimeter. So we can write the thickness of the soap bar is 3 centimeter. Next, problem number 3. How many bricks of length 25 centimeter, breadth 15 centimeter and that of height 10 centimeter are required to build a wall of length 6 meter, height 2.5 meter and that of the breadth 0.5 meter. So friends, here given things are, for a cuboidal shape brick has a cuboidal shape whose length is 25 centimeter, breadth is 15 centimeter and height is 10 centimeter. So length, breadth and height of this brick will consider L1, H1 and B1. So cuboidal shape wall has a length L2 6 meter, height S2 2.5 meter and that of the breadth B2 is 0.5 meter. So friends, here wall has a dimension in terms of meter, whereas brick has a dimension in terms of centimeter. So we have to convert here the dimension of this wall from meter to centimeter. Here we have to find out the number of bricks required in order to build a wall. So when the bricks are arranged to build a wall, the volume of the bricks is equal to the volume of the wall. So number of bricks required will be volume of the wall upon volume of the brick. We will put the value, that is the volume of this brick is equal to L1 into B1 into H1, that is 25 into 15 into 10 cc. For the wall, L2 is 6 meter means 6 into 100. We know that 1 meter is 100 centimeter. So 6 into 100, that leads to 600 centimeter. S2 is 2.5 meter, that is 2.5 into 100, 250 centimeter. And B2 is 0.5 meter, that is 0.5 into 100, that leads to 50 centimeter. So volume of the wall will be L2 into B2 into S2, that leads to 600 into 50 into 250 cc. Friends, we know that number of bricks required will be equal to volume of the wall upon volume of the brick. And volume of the wall is 600 into 50 into 250 and that of the volume of the brick is 25 into 15 into 10. After simplifying this, means carrying the division, we are getting 40 into 2 into 25 and the multiplication of this is 2000. So friends, the wording answer will be 2000 bricks are required to build this wall. So I think you got this. Let us turn to the next problem number 4. For rainwater harvesting, a tank of length 10 meter, breadth 6 meter and depth 3 meter is built. What is the capacity of the tank? How many liters of water can it hold? So friends, here given things are, for a cuboidal tank is a cuboidal shape whose length is 10 meter, breadth is 6 meter and depth is 3 meter. Depth means height we have to consider here. Friends, the dimensions are in terms of meter, that we have to convert it into centimeter in order to have a capacity, how many liters of that tank can hold. So capacity of the tank we have to find out, as well as how much liter of water it can be holding. L is 10 meter means 10 into 100. 1 meter is 100 centimeter. So 10 into 100, that is 1000 centimeter. Breadth B 6 meter, 6 into 100, 600 centimeter. H is 3 meter, that is 3 into 100, 300 centimeter. Now we'll calculate the volume of the tank, L into B into H. So 1000 into 600 into 300, that is leading to 18000000 cc. Now capacity of the tank is nothing but the volume of the tank, which is 180000 and 000 cc. We have to convert it into liter. So we know that 1 liter is 1000 cc. Divide this value by 1000. So 18000000 upon 1000, that leading to 1,80,000 liter. So friends, in word, the capacity of the tank is 18000000 cc and it can hold water around 1,80,000 liters of water. So friends, I think you got this all problems. So today what we discussed is, in this session, following subtopics. Number 1, surface area and volume of the 3D figures, cuboid formula and surface area of the volume for the cuboid, for cube also formula and surface area volume. So friends, will you try these problems? That is, First one, a cuboid has the three mutually perpendicular edges measuring 5 cm, 4 cm, 3 cm. Find its volume, its surface area, and the length of the diagonal. Second, the length, breadth, and volume of a cuboid are 8 cm, 6 cm, and that of 192 cm cube respectively. Find its length, height, surface area, and lateral surface area. If the edges of the cube measures 5 cm and find its volume, its surface area, and the length of the diagonal. If the surface area of a cube is 96 cm square, find its volume. So these 4 problems you try at the home, will get practice it. So friends, you should not forget the famous words of James Joseph Silvestro, an English mathematician. He said that mathematics is the music of reason. Very nice wording. So friends, with these words I would like to say thank you.